As I mentioned before, Python is an object-oriented programming language. And next we will start studying the concept of object-oriented programming, why we need it, what it is, how it works, and so forth. Let's see first why we need it. It supports the concept of abstraction in programming. Right, everybody likes cars, or most people like cars. So let's see what we have if we do not employ object-oriented programming style. Let's say we want to keep track of 4 different attributes of a car. We'll say it's make, model, year, and color. So we will have 4 variables for car 1. Let's say it's Mercedes-Benz AMG GT Roadster 2019 release, and it's of black color. And we could print all of this like this. But now say we have another car, we'll call it car 2. Well, guess what? We have to reproduce all of those variables for car 2. Car 2 make, car 2 model, car 2 year, car 2 color. And let's say we have Chevy Cruze 2018 and it is yellow. Well, we have another car, car 3. It's a Ford Mustang 2017 brown. And what if we have a million more cars? And there's nothing wrong with this logically. If you make all of those print statements, you will get these results, right? 2018 yellow Chevy Cruze. But the point is, there are far too many variables. And I hope you know that in like a regular kind of car thing, there's not 4, but thousands and maybe tens of thousands of different variables. And say we want to keep track of a few million cars, different cars, right, of all different years, makes, models, and so forth. I hope you can see how it quickly can get out of hand. And even if you employ lists or arrays to store all this stuff, it is far from user-friendly, and you will soon run into a lot of issues maintaining your code and your data as a programmer. What is the power that the object-oriented programming gives us? Well, consider this syntax. It prints the same thing, but now instead of having multiple variables per car, we simply have car 1, car 2, and car 3. And then we say that car 1 gets this object type, the class of car, and we just put all the variables in order, plus there's one more variable we can put. We'll see what that is shortly. And you can put many more variables. Well, if you don't declare the class of car, you're going to get an error, right? Because what is this car? But then simply calling print stir on our cars, we get the same output as we got here. Look how many variables and what a mess this is. And this is relatively neat. But what this person is confused. What is this car? We haven't seen a data type called car. Like that doesn't make sense. Okay, so objects and classes. An object is what's called an instance of a class. I told you we'd come back to classes later, but recall what the function type gives you. If you call type on the number 1, it's going to say it's a class of int, class of float, class of string, class of list, right? We saw that. Pretty much everything in Python is an object of a class, right? And the power of object-oriented programming is we can store arbitrary data within an object and then neatly and easily access those data. So convention is that class names need to be capitalized, as you'll see shortly. Object-oriented programming does support our concept of abstraction, and we want to abstract as much as possible. Right? You can define your own custom types. Think about this. This car is a custom type that we will define very shortly. Python doesn't have a data type of car, yet we created it. You create it, you define it, and then you can use it. The power of this cannot ever be overstated. It is incredible what object-oriented programming can do for us. Now, I mentioned before this function versus method, and I said a couple of segments ago, I called something a method, and I said, don't worry, we'll come back to it. So what is a method? Method basically is a function. It is a function, but if a function is contained within a class, it is called a method. So remember that list.append item, I said it's a method. Well, list is a class, and it's not simply a function append by itself. Then it would be called a function. You say def append something else. But if you define it within a class, it is called a method. So append is a method of the list class. Right? And what methods do, they define behavior of those custom data types that you define, right? And it's important that you understand that the methods only operate on the objects of that class. You can't declare a method for object A, of object of type A, whatever it is, and then call it an object type B. You're going to get errors, unlike functions that can be called on pretty much anything. Now, what is that car? At this point, I'm going to switch over to my Windows 10 lab machine and open the file cars Python that you can find in your downloaded materials. I encourage you to switch over as well and follow along. Let's take a look at the header. So it's cars.py, and it demonstrates the concept of objects. Here are my comments. Okay, we have a few new things here. We said we define an arbitrary class. So how you define a class is you say class space, class names are capitalized, and then it's the same structure as in a method or in a for loop. So you have a colon at the end of your class, and then the entire class definition is indented. As soon as indentation is done for the class is over, and whatever comes next is outside of the class. We will consider all these methods in detail in the following lecture, but right now let's just take a look at them. The underscore init underscore method, and the same underscore stir underscore methods. So just one thing we want to note here is that these underscore methods are very special in Python, and they have a specific purpose, which we will see later on. But let's just look at the comments. It instantiates a car object. An object is an instance of a class, so it instantiates an instance of a class car. It takes arguments. For now, let's ignore this self argument. It sounds kind of weird. We'll come back to it in a little bit. But it takes our make, model, year, color, and that last number parameter is actually odometer reading. So here are all the definitions of these arguments. And init is short for initialize. We are initializing this object. And we assign all of these variables to the internal variables of the object. Now the stir predefined and reserved Python method, it simply gets the string representation of whatever the object is. Each object should have a string representation of its internal state, and it's often very important to be printing to console, at least for debugging purposes. Okay, so this next method is now, we've seen this kind of definition. It's almost the same as function, right? So it says get, make, and model, and it takes self as a parameter. Again, ignore these selves for now. We will see them later. And it simply returns the make and model of the car in the shape of a string. This travel method takes, again, self, and it takes distance. And the distance will say it's simply the number of units traveled. Units are either kilometers, miles, if it's a model car, maybe centimeters, I don't know. And look what it does here. It updates its own internal odometer state. It increments it by the distance, and we will see examples shortly. And finally, the get odometer, what it does, it gets and returns the current odometer meter reading for the car, right? Okay, so that concludes our definition of a class. And don't worry, this may seem overwhelming. We will consider each individual piece later on. But now let's jump to our main method. And as we saw in the slides, we will instantiate 3 objects of cars: car 1, car 2, and car 3. How you instantiate an object, you first shove it into a variable, and then you call the class. You open the parentheses to pass all the necessary arguments. Again, don't worry about that self parameter. You ignore it when you are creating an object. And you have to know what the other parameters of the init method are and in which order. Obviously, order matters a great deal. And then you say, so for the make, we pass Mercedes-Benz. For the model, it's our GT roller coaster, then the year as an integer, color as a string, and the odometer reading for 100. And we do similar thing for the other ones. And again, as we saw from the slide, it is very easy to print objects if you predefined their stir method. So by calling stir, what it in fact does, it calls implicitly this reserved stir method with underscores of Python. And that is what this method returns, right? So we should expect by calling that method, we simply get that representation of cars. So now let's see what this prints out. I will invoke this file with python cars.py and enter. Sure enough, it printed the same thing as we saw before. So the year, color, make, and model of a car. There probably should have been some commas or punctuation, but that is not relevant at this point. Now, what also follows from the power of object-oriented programming is we can append, we can make lists of our objects. Now, look what we're doing here. I'm going to save this file, and I will comment this out, these print statements. Here, we're declaring a list of cars, and we initialize it to the empty list. And now we simply append our 3 cars, cars 1 through car 3, to the list. What we can do now, instead of having 3 print statements, if we have now a list of car objects, we can go for car in cars, so collection controlled for loop. We're going to loop through every item in the list of cars, and we're going to print not only the stir of car, but also we will append its odometer reading by calling this getOdometer method. Right, car.getOdometer, and it's defined here. So it simply returns the odometer reading for each car. Okay, so we'll save the file, and we'll see what this does. I will leave this output so we can contrast. See, so the same thing as before, but now we also concatenated the string of each of their odometer readings. So now, again, see, if we do have a list of objects and not just objects, instead of all these print statements, and you would have 1 million of them if you have 1 million cars, right? If you already put them all on the list, it's 2 lines to print all of them out, or do some other operation or manipulation on the object. You simply do a for loop and then do whatever you have to do. Okay, next, let's get simply the make and model of the second car. So what we will do is I'm going to copy paste this statement here. So we are printing, the object we are referencing is car2. We say car2 dot get make and model, and we pass no parameters. Again, ignore the self parameter of the method. And get make and model is referenced right here. It returns concatenation of make and model. And so we will comment this out and print out. Now I'm going to clear the output, and we will print out the second car. It is a Chevy Cruze indeed. All right. So let's see, we said that cars can travel, right? And let's make the first car travel a little bit. What we say is car1 dot travel, and then we pass the distance as a parameter. Now, if we look at the definition of this method travel, besides the obvious self, it takes distance, and then it increments its own internal odometer reading only for that car, mind you, for that object of the car. It increments it by the distance. Okay? And then, after we do that, we will get the odometer reading of that first car. So first it will travel, and then we will get its odometer reading. So as you remember here, the first car starts at a travel distance odometer of 100. Now, if we execute this, clear the output. So what happened here, so we first traveled 500 units on car 1, and when we did that, we updated the internal state of the odometer reading of car 1 by 500. It used to be 100. We added 500 more units, and when we go the get odometer, now we want to observe what is the internal state of that variable, it returned 600. Now it might be tricky to understand this, but in the following lecture, we will take a closer look at each of these elements and see them in more detail.